Good evening, everyone, and welcome to another session of ShareIT. My name is Emil Trebitska, and I'm a software developer in ThoughtWorks Italy. And together with my colleagues that are in the call today, Ronnie, Matteo, Pallavi, and Gayathri, we will present to you another session of ShareIT. Before passing the mic to the speaker, I will take 2 minutes of your time to talk about what ShareIT is and about the conduct for this event. So ShareIT is an initiative organized by ThoughtWorks Italy. ThoughtWorks is a global consultancy company present in a lot of countries around the world. In Italy, our offices are based in Milan, although we are working mostly remotely, like I'm based in Padua. In ThoughtWorks, we put a lot of emphasis in learning and also in teaching. A lot of our colleagues have written a lot of books. We have the speaker of today has written one of them. So we are trying to follow the tradition of teaching through these events, through this initiative that is called ShareIT. So what is ShareIT? The mission of ShareIT is to empower individuals and organizations. How do we do it? We do it by sharing our experience in projects, not only in projects done here in Italy, but also in projects done around the globe. We usually talk about tech things, but also we talk about agile practices, design, and even diversity and inclusion that is very important for us. When we come to the code of conduct, so be kind and respectful to each other. We want a safe environment where anyone can ask questions. You can use the Q&A feature in order to ask those questions, and my colleagues and I and the speaker will try to answer them at the end of the session. Keep in mind that we may have different level of experience, and we are all here to learn from each other. So let's be kind and have a safe environment altogether. And over to you, Gayathri, for your speech.
Thank you. Let me share my screen. Can you see my screen?
Yep. Yes.
Awesome. Cool. So I'm very glad to be here as part of the ShareIT initiative and with my colleagues. So as Emil was talking about, this is my introduction. I'm Gayathri Mohan. I am from originally from Chennai, India, and currently located in the UK. I'm a principal quality analyst. I played the roles of global QSMA at ThoughtWorks Capabilities. I'm also part of the Tech Advisory Board at ThoughtWorks India. Recently published a book called Full Stack Testing with O'Reilly. I've also co-authored Perspectives of Agile Software Testing ebook long ago. So this talk is about full stack testing, particularly we'll be concentrating how the testing discipline has grown so much over the years and how it is unfairly represented as just manual and automated testing still. So this is going to be around those lines. What does full stack testing means today? How it has grown hugely, both breadth and depth wise. Around those lines, to build the topic, we'll be talking about what is software quality to start with, and is software quality even worth the cost that goes into it? And we'll be looking at full stack testing, which is a composition of process, techniques, and tools, and a lot of principles that goes along with it. So this will be our primary focus today. So let's begin with aligning ourselves on what is software quality. I think many of us would have an opinion about what is software quality. We have all been in some kind of projects or as even a user, end user of a product, will have an idea about what is software quality. So being both on the project, delivering some software, and also as an end user, what does it mean to us? So if you're an end user, we would have heard definitions of quality, like I want the software to be usable, I want the availability to be there, my data needs to be private, the software should be secure, customer support should be available, ease of use should be there. All of those are end users definition. Even if we are the end user, we'll be probably asking for all of these things and lot more as well. And if we ask the business that is funding the software and the product functionalities, they will have a separate definition of what quality really means to them. Like we might think that functionalities are good enough for the business for them to pay us, but what is really quality means to the business itself is something very different. So they might be asking for no vendor lock-in. They might be asking for features like scalability. Like you have to build some functionality, but it should not just stay within the region, but it should also be scalable. I should be able to quickly scale it to a new region, expand globally. Reusability. There would be multiple components that can be reused across their enterprise. If it's like a big organization, even the UI component should be a reusable component, not only just the services or the backend functionalities, but a header component could be something that can be plugged into all of their products like mobile or web applications. Reusability is very key aspect that the businesses define as quality when we are building or delivering a software to them. Maintainability, legal compliance, because all of those are like they are kept answerable to all of the legal entities, and so it's very important for them. And infrastructure costs. Finally, at the end of the day, it's not only the revenue that they get from the product, but also the costs that are associated in hosting such a product. So the comparison versus the spend and the revenue makes a big difference in what the type of quality of the software that we are delivering. So you can see there are multiple lenses in looking at the same product functionalities. The product functionalities will be the same, like booking a product in a e-commerce application, but the lenses with which the end user is looking at it and the business client is looking at it will be very different, and they will be calling everything in the lens of quality. The product is not meeting the quality. So understanding that this diverse lenses exist first, and then looking to build quality into the software, and how testing is going to help in building that kind of a quality is something that we'll be looking at in the future slides. So in summary, software quality was once equated to a bug-free application, but nowadays, I mean, functional defects are no more the definition of software quality, but there is more to it. And any software that doesn't meet any of these criteria, right? Like that will be called a subpar quality. And you have so many competitors in the market today. Every product has two, I mean, not just two, and sometimes more than 10 competitors selling the same kind of services, selling the same kind of items at a more usable way or more convenient way to the same set of audience in the same region. So which means if you are actually losing the quality game, then you are actually losing the game. I mean, losing the competition itself. Any subpar quality is equal to running a losing game. And you have many examples in the past that have happened across the globe that proves us this statement, that subpar quality is a losing game again and again. For example, some of you might remember the Flipkart's Big Billion Day sale in October 2014. I think Flipkart is one of the e-commerce applications where they did a lot of marketing to get a lot towards an event, like a festival event in India. And along with Flipkart, other e-commerce applications also went through the same marketing procedures to achieve their sales target in the festival season. But after all that marketing, what happened was the site couldn't actually handle the load that was coming in, and it lost all of its sales to its competitor Snapdeal. And eventually the customer trust also went down, and the trust, along with the trust, the sales and the the number one position also went down slowly, and they have to win back their trust and win back their reputation. It's a long game. Similarly, Yahoo, I'm not sure how many of you would remember or even had Yahoo accounts. At least I had a Yahoo account before. And you can see how the trend of having a Yahoo account slowly changed into Gmail. They faced, because of their lack of quality in the search product, and there was the biggest security breach in the history that Yahoo faced as well. Another example, Raychat, an Iranian startup, once again fell prey to ransomware attack. It was a booming startup, but did not focus enough on the security aspects, and the customers were let down. So all of these are examples where there were a competing product existed, and it is always a competitive market where we are running against each other, where the business is running against each other to win the customers' trust and do long-running business in the market. So if they focus only on the product, and if they only focus on selling a product and not on the quality of the product, this is where they land. In summary, I think quality is quintessential to sustaining a business in the long term. We could actually argue that we need to actually release a product to test the product's viability and get quick feedback, but without implementing any of the quality aspects. But that means that you have only accumulated a lot of tech debt or quality debts that you need to implement later, which is going to cost a much more later in the later stages. So it is all about the running in the long term, sustaining in the long term. I think quality is going to be really utmost of importance. How do we build quality in? So now we have touched upon the point of how software quality is defined, and how certain companies have let their customers down, and how they've lost the running race in the market. So what are the things that we should be doing to build a high quality software? So it's like a really obvious thing. Quality is team's responsibility. It doesn't, we are not going to equate that testing is the only way to induce quality into a product. Quality is going to be imbued into every step of the software development cycle. It starts from actually collecting requirements and including all the quality parameters in the requirements itself. For example, users should get results in X seconds. When whatever actions they're doing, they should be able to get the results in X seconds. That's a requirement gathering phase. If we are actually attacking those problems, that's imbuing quality in the requirement gathering cycle. Quality during design phase. Design of the application should also make sure that there should not be multiple buttons to click, so that the response the response time actually is longer for an end user to achieve their goal. So imbuing the design quality in the design phase is also an important aspect. Similarly, I think quality in development, skillful development contributes to high quality, and it's just not, without that, we are not able to get to anywhere at all. And finally, I think testing for quality is like, once again, meticulous testing is going to be absolutely critical for building a high quality product. So it's like you have collected the right requirements, you have collected the design that will cater to quality, you have built the software with all the quality attributes. Now you will have to give feedback whether it is meeting the end user's definition of quality and also the business's definition of quality. Sometimes even the development team will have their own expectations on the quality of the software, like readability of code and all of those things. So this feedback loop of seeing whether the software has met all of those requirements, it comes under the testing criteria, testing discipline. So it's going to be absolutely important that testing is done for all these criteria, and that is what we are going to talk about in full stack testing. And we have spoken so much about software quality, and whenever we actually have this conversations, we also get to hear this question: is software quality worth the cost? Can we not really prioritize product to market over software quality? Is it really worth spending that much effort? Are we spending too much on all of these aspects in terms of software quality? But I think one of the things that I like about Martin Fowler's article, it is really, an abstract concept, right? Like software quality is very abstract. And Martin had clearly put this in a graph, how quality impacts even feature delivery, leave of whether the end user or the business is actually benefiting from any of the criteria that we measured, but even the pace at which that we will be delivering the features is going to be faster when we are able to imbue the right quality parameters from the beginning of the project. So you can see the x-axis is time and the y-axis is the functionality that gets delivered, and the blue line represents the high internal quality imbued software with high internal quality, and the brown line talks about the software with low internal quality, or something that that I haven't paid attention to in inducing the quality parameters into the software. What happens is we talk about product to market, and it all actually only in the beginning. So the rush to go to the market without by trading off some of the quality aspects will prove to be really fruitful in the initial few stages, but as you see with time, you'll be seeing that your efficiency to actually produce more features will also come down, and the software that is imbued with all the quality parameters will be faster to deliver, and the exponential difference between these two lines shows how it is how it is effective in cost saving as well, right? Like even though there is an initial slow period where it looks like as if all these quality aspects, the testing, development, requirement gathering, all of those things seems to be slowing down, but with time you will see that the software that has these practices and these kind of techniques stitched into it seems to be delivering a lot more value over time. So that's a very crisp answer, and I think an answer that is very uh, uh, that's very convincing in his article in various ways. And this is a diagram that shows exactly how we have experienced with the right practices being induced into the software as well. So coming to the testing part, now that we have spoken about all the fundamentals and looking at testing aspects alone, and looking at the different techniques and process and principles that will compose the full stack testing, and how that is leading to a high quality software. When we talk about testing, I think when I initially mentioned as well, we usually say that, okay, we need to do manual testing, we need to do automation testing, right? Like, but if we look at a simple application which has the UI layer, services layer, and the database layer, there are so many different testing types that we need to be doing at each layer. Like if we have to look at the database, it has an infrastructure that is hosting it. So we need to actually look at the security of the data integrity, the reliability of the infrastructure, and so many other legal compliance aspects when it comes to database. In the services layer, similarly, there is performance, there's a functional aspect, there's security, authorization, and so many others, even within the services layer. It's just like no more manual and automation, right? Like manual and automation against each of these criteria is like, it's just like a broad dumbed down version of what testing is in those particular layers. Similarly, in the UI layer, if we look at, we have to do for visual testing, front-end performance, accessibility testing, and so many other quality aspects that we'll have to pay attention to at each of these layers. And that involves meticulous testing that I was talking about, and building that into your continuous delivery cycle. So this entirety of testing is what I'm representing as full stack testing here. And why do we, and there are like ways to achieve this also, like we could do we could say that, okay, at the end of the delivery, we are actually at the end of the development, there's going to be a testing team which does manual testing for all of these aspects and then going live with that. But what we are talking about today is how to full stack testing to enable continuous delivery as well. So it's just like not like a big bang waterfallish delivery, but testing for all of these aspects and integrating with the continuous integration pipelines, automated integration pipelines, get feedback on a continuous basis, and be able to release the software as and when the business demands it, which is like could be on a daily basis, or it could be on a marked date like a festival dates or something. So we are talking about the building the ability to be able to do continuous delivery by testing for all of the quality parameters and not just the functionality, the acceptance criteria on a high level. So to do that, I think we need to understand three things. What's the process, the techniques and tools involved, and the principles that will help us to evolve the things as we are going through an unknown zone. So the process for full stack testing, I think we will high level, we have to actually, I'm sure many of you would have heard as well, the shift left testing practices have been widely spoken about. We'll be talking about briefly about the extreme programming practices, which also talks about shift left testing. And the techniques and tools. So apart for manual exploratory testing itself, there are a lot of techniques. Manual exploratory testing is broadly at a very high level, but there are a lot of techniques inside it to approach a problem statement. Similarly, there are cross-functional requirements testing. There are a lot of techniques there, visual testing, accessibility testing, and security testing, and so many of the aspects that comes under cross-functional requirement testing. And in today's world, there are a lot of tools that supports these kind of testing, and that can be automated and integrated with the continuous integration pipelines as well to enable continuous delivery. So those are the techniques and tools we'll shortly look into as well. And as I said, principles, guiding testing principles, because whatever the tools and the process we might be following, it's just that as the every project is going to be new, every challenge is going to be new, imbibing that principle will help us to attack the problem statement in a proper way. So these are the three things that we'll be looking at next. So process. Full stack testing process, I think, as I said, to do continuous delivery, I think, and to imbue quality in all of the requirements phase, design phase, the development phase and the testing phase. And that's what is shift left testing talking about as well. Being able to validate the requirements at an early stage, being able to validate the design aspects. Like, for example, accessibility starts with the design itself. Like, the design has to make sure that the layout is consistent. The colors of the design, colors of the page design has to be in a certain contrast ratios. All of those things needs to be verified at the design stage itself. And development stage testing as well is very, very crucial to get that fast feedback and the testing phase, and then be able to release it immediately. So all of those things form the shift left testing fundamental. And this immensely, what it actually yields us is it immensely reduces the time taken for defect identification, first of all, and fixing time as well. Imagine you actually wait till you get your defect after completely completely developing the entire feature, and you get your defect after 2 months. You have develop that first story. That's going to be like even the developer who did that story, developed that story, would have forgotten what he did 2 months ago. And it is going to take a longer cycle to fix the issue. And sometimes even it is going to be impossible for us to rightly fix the defect. That's the cost of fixing the defect could be that you have to change your architecture as well. So those are the implications that the shift left testing process is trying to alleviate and give the opportunity to the team to get shorter feedback cycles, early feedback cycles, and give the team an opportunity to catch and fix the issues at the earliest possible opportunity. So if we take XP, like we were talking about the extreme programming practices, it has come up, I mean, it has been there for a very long time. Ken Beck introduced a long time ago, and there's something that ThoughtWorks follows as well. So there are a lot of practices that are like the Three Amigos process, the design, prototype validation, iteration planning meeting, story kickoff, that happens before the development of the story starts itself. So which means that the opportunity to find issues on the requirements itself is happening before development. These are not actually time consuming activities as well. These are all like short, quick meetings that happens, but the amount of value that comes out of these short interactions is going to be really huge, because the inputs from all the angles, like the design is validated, the requirement is validated, the integration inputs will come in. So you're making sure that before the story is passed on to development, the story is fully mulled out in terms of any edge cases or any integration points, and then passed on to development. So you are cutting down that feedback cycle, or you're actually pushing that feedback cycle earlier, or otherwise what would have happened is like you would have got that edge case or that integration scenario or a regression defect like much later in the cycle. So during development, I think it's a common practice to write unit tests. There are linters to give fast feedback. There are tests that are run in the local machine. There is also CA/CD pipelines, and also there's a process called DevBox testing. So if you see, there are multiple feedback loops here where the developers can get feedback on all of these quality aspects uh, by running on the test on the local machine itself for the local changes, but also on the CA on a broader perspective on all of the quality aspects. And moving to the manual exploratory user testing phase, we can see that the phase is, once again, manual exploratory user testing is one of the critical phases where you get the input from all angles. Like so far, the developer would have focused on the technical aspects of it. The BA could have focused on all the business angle of it. And when it comes to exploratory testing, the focus will be on the end user, and the exploratory testing will understand that the business requirement is this, the technical architecture is this, but the end user's needs are this. So given all of these parameters, the exploratory testing will pop with a lot of edge cases there. And that's going to be immensely valuable to identify and also challenge the requirements that have been gathered, and the technical architecture, the technical way it has been delivered, developed. And it's going to be a crucial stage to challenge all of these things and to unveil some of the unknowns of the software itself. So I mean, it need not be just the functional requirements part. It could unveil a lot of cross-functional aspects as well. You could figure out even during manual exploratory testing that a page is really slow to be loaded. So those are some of the quicker feedback loops, the fast feedback loops that comes out of manual exploratory testing. And the manual exploratory tests are automated, added to the CI/CD pipeline, and continuously the cycle of shifting the feedbacks in short loops for every single user story. Make sure that every single user story is ready to be pushed to the release as and when required by the business. So In short, we are saying that we'll be ready for continuous delivery if we follow some of these extreme programming practices. Techniques and tools. So coming to the second part, so we spoke about three things: process, techniques and tools, and principles. So coming to techniques and tools, so uh, we are going to look at a model called the FERPS model. Right? The FERPS model is like a really old model, somewhere in 1960s. This was released. What it says is the software requirements can be gathered into these 5 buckets of requirements. So that's the acronym: functionality, usability, reliability, performance, and supportability. So functionality is a category of requirements that can be realized as a user flow. So any requirement that comes as a user flow is like bucketed into a functionality, And usability is a category of requirements that comes with user experience. So the reason why we are actually looking into this model is I'll be introducing the techniques and tools to test these kind of requirements. So typically, any software will have requirements that can be bucketed into these 5 aspects. And once we know the techniques and tools that are available to test and automate or add it to the CI/CD pipelines, we know that the entirety of all the software requirements can be how to be tested using these techniques and tools. That's the idea of presenting this model in the first place. So we were talking about usability. So category of requirements that affects the user experience, like user experience in sense, that's the end user experience. It could be something like an ease of use or accessibility, user use, the design aspects. All of those kind of requirements will fall under the usability aspect. The reliability aspect, I think it's one of the crucial things. These require whatever that requirements that makes the application fault tolerant. All of those things fall under reliability. So fault tolerant, it could be something like you stress the application, what happens when it is stressed. So all of those kind of expectation on the software are captured under the reliability bucket of requirements. Performance, I think well-known terms. I think performance KPIs are well established. The availability, concurrency, throughput, all of those things are performance category of requirements. And supportability is an interesting bucket of requirements. So this bucket of requirements talks about many things, especially the evolutionary code qualities. Like, for example, the maintainability of the code, the testability of the code, whether the code is written in a secure, with security in mind. So all that supportability aspect, which defines how the code evolves, what the code qualities are bucketed into the supportability category of requirements. So now if we look at these 5 buckets of software requirements, what are the different testing techniques and tools that are available to us today? So this will give us a picture of how wide the testing field has become today. As you can see, there are so many different types of testing techniques available. We'll get into the tools in the next slide, but to go into each and every section and dive deeply into each of those sections, we can see that the functionality bucket has manual exploratory testing. There are functional test automation. So when I say functional test automation, it is not only about the end-to-end UI test. So we keep talking about the UI test as the ultimatum of functional test automation, but it's not just that. The functional test automation includes all the unit integration, contract, end-to-end tests. It's a variety of tests that have been that can contribute to testing the functionality and automating the functionality. It's a broad class of testing in itself. Data testing. Data has become one of the crucial aspects these days, and there are different data systems in place, like the event-driven system, batch systems, the caching mechanisms. And so each of these systems needs specific attention in terms of ensuring whether it is meeting the requirements or not, whether it can, and also the automation techniques that are available to ensure that they can be integrated with the CI/CD pipeline and make sure that they are also made ready for continuous delivery. Usability requirements, I think visual testing, it's a technique where we can actually take screenshots of the screens and compare it with the expected design. So it can be done for web application, it can be done for mobile applications. It can be very useful to give feedback on the visual aspects. As we saw earlier, visual aspects are also become very, very critical these days, that that it has advanced so much that there are paid tools that are thriving really well. User experience testing is another category of testing technique, where we are talking about not the um, application after it has been developed. We're talking about the testing that needs to happen at a design level, whether the user experience, the design part, is really applicable to the set of end users that we are targeting the application to. So there are a set of tools that are already in place to get feedback on the design aspect. Similarly, accessibility testing is, there are legal requirements these days for the companies to meet a certain type of accessibility levels. So if they are not able to achieve that level, there are companies that are getting sued as well. And accessibility testing has become one of those essential testing techniques. And there are a bunch of tools that can be used to automate and integrate with CI/CD pipelines as well. Reliability, I think we spoke about stress testing, and chaos engineering is another way. Chaos engineering by Netflix was introduced, and there was a book recently released as well a few years ago. Chaos engineering is a great way to figure out whether any unknown issues are present in our entirety of the system, and to unveil that broken pieces and reveal the unreliable component. And infrastructure testing, once again, infrastructure testing is, although we can, it's an upcoming thing, you can see that infrastructure is going to be the backbone of the software one. And if you have to scale infrastructure to another, if you have to scale the software to another region, you need the infrastructure to scale as you want to go as well. So basically, testing infrastructure as code and making sure that you are providing a stable environment where your application can hold itself stably is going to be critical as well. Performance, we know there's backend performance testing, there are separate tools for it. Front-end performance testing is also something that has been there for a very long time. There are multiple tools that are there as well. All of these three are, as we can tie it back, we have to actually bring up reliable components, reusable components, maintainable components. We also need to be able to do continuous delivery. So applying those lenses, I'm just trying to connect back to how these testing techniques are connected with each other. Supportability, once again, I think this is an interesting bucket of requirements where we have very varied kind of testing techniques to ensure that the supportability kind of requirements are also tested. So these are some aspects that are, sometimes it may come across as really vague because it's just like not so prevalent. But there are really good testing techniques available and testing tools that are available to ensure these vague requirements like maintainability, readability, reusability, all of those things can also be tested and automated using these kind of testing techniques, like architecture fitness tests, or static code analysis, dynamic code analysis, linters. All of those things will help in addressing some of these supportability bucket of requirements. We'll get into the tools shortly and you'll understand what we're talking about. So the tools, to give you example, these are the Postman, browsers, or Bug Magnet, all of those things. I think that is some kind of an established tools. So, but this is to give a broad view of how much the testing field has grown these days, that each of these have unique capabilities that help you accelerate your continuous delivery process. Manual exploratory testing itself has so many different kinds of testing tools that gives different insights by using them. There's functional test automation, as we said, there's services, the contract, there's integration. There are so many levels of functional test automation. There's data testing, there are test containers, DQ, great expectation kind of tools that have come into picture today to enable to do data testing. Similarly, these are tools that are available for visual testing, Cypress, Apply tools, user experience testing, A/B testing tools, use Zoom, Optimal Workshop, accessibility testing as Axcore, Lighthouse, Wave. So each of these are not just like subjected to whatever it is mentioned here, but there are a bunch of them are available today actually. So it's just like you have different capabilities available in different tools, and the field has grown so much, the expansion is so much that each of them are coming with its own benefits nowadays. The reliability part, we were talking about JMeter, Gatling, there's a UA monkey for stress testing, and chaos toolkit. In the chaos engineering field, even though it's a new field and it's like recent developments, we can see so many tools that are available to simulate this chaos engineering practices. And the companies also follow a very great culture of game days, sit together, make sure that the reliability is ensured. And infrastructure, it's a very broad bucket of tools that are available, like TFLin, Kitchen, Terraform. Even the complaints aspect, policy as code kind of tools are also available at the infrastructure layer. Performance, needless to say, I think many of you would have even heard about a lot of these tools available. Lighthouse, web page test, Chrome Dev tools are all front-end performance tools, apart from JMeter, Gatling on the back-end performance side. And supportability part. So coming to architecture fitness tests, like the JDIP and ArcUnit net architecture kind of test actually helps in identifying whether the architecture requirements are in place. Like if a component has to be, like for example, it needs to be an independent component, that it needs to be not tied to another packages, and it needs to be reusable. So all of those things can be added as tests at that particular layer itself, and made sure that any kind of violation in terms of reusability, or they are creating some dependencies, the feedback is given to the developer then and there. Static code analyzers, like to actually ensure whether the code is readable, you have the check style kind of tools that are available, make sure that the styling is proper, and it's consistent across all the developers. All of those things are available at a very early stage, like as in the static code analysis itself, and not just wait for the functional test automation or any manual exploratory testing to happen also. So it is at a code level, giving feedback then and there. And there are dynamic code analyzers like Zapdast, which is like a security tool that actually attacks the application on a dynamic basis, changes the code, attacks the application, gives you results. There is a PA test, which is a mutation testing tool that also gives you feedback on whether you have written the right unit test itself. So SonarQube kind of tools gives you code coverage, but mutation testing tools tells you by whether you have written the right unit test or not by changing the code, and actually seeing whether the unit tests have failed or not. If the unit test hasn't failed, which means that the unit test doesn't cover the change in code, there is a missing scenario or missing, right? We have to actually change the unit test. Those kind of feedbacks are available by these tools. Linters, for example, there's a lot of, linters are a great way to catch many of those feedbacks at a very early cycle. Like, for example, cross-browser testing is done at a very late stage, like when people have to do manual exploratory testing on multiple browsers. But linters can give that fast feedback. That's the shift left aspect that we were talking about. These kind of linters actually tell you when we are coding that whether a feature is available for the supported browser or not. So those kind of aspects, as you can see, many of these tools bring in that aspect of shift left testing and the fast feedback mechanisms, and also enable us to do the continuous delivery cycle by adding it to the continuous integration pipelines and giving feedback on a continuous basis. So these are the testing tools and techniques. So that with that we have covered the second part, the process and the techniques and tools. But now we'll combine the process and the techniques and tools and see how it fits together. So if you have to combine the process, the shift left testing, and then the testing tools that we looked at, what will be the shift left security testing process for the overall cycle? So during development, you'll probably start with the SAST or SCA tool like Snake and OWASP's dependency checker, and even pre-commit hooks like Talisman exist, making sure that during development you are getting that feedback. And even before development, there are threat modeling exercises that make sure that the requirements in itself is validated as a practice. And during CA/CD's phase, we have all these tools running in CA/CD across the repository of code. There's functional automated security tests that can be written. Like, for example, there are several functional user flows that attribute to security reasons, like a banking domain. If we take, the account should be visible only to the individual who's owning the account, and probably the bank manager can view the privileges to view the account total, but none of the others should be able to view the account details. So that's a security functional flow, and those things can be automated in a functional category. Like you could write a unit integration or UI test or service test, whatever it may be, and cover it in the functional automated pyramid. Image vulnerability scanning that can actually give you feedback on the infrastructure layer. There's DAS test that we spoke about, giving feedback on the code in a dynamic by changing the code, by attacking the code dynamically. And once again, manual exploratory testing can reveal a lot of security scenarios and expose the issues that could be there. Like, for example, looking at the logs also is like looking for private information. The privacy aspect, data integrity aspects, a lot of things can be covered as part of the manual exploratory testing phase as well. Release pen testing is like a standard thing that we have to get certification, and depends upon the application as well, like how serious your application is, and whether we want to go via an authorized entity and get that pen testing done. And there are RASP tools, runtime application security tools, where these are put in production, basically to monitor the incoming requests and make sure that the request patterns are similar. And if there are new different type of requests that are coming in production, these tools actually make sure that they cut off those kind of requests and ensure that, prevent from attacks. So instead of actually, so far we were talking about tools which are catching the defects before going to release, and in production, these kind of tools actually monitor and prevent attacks. Similarly, front-end testing, and I think there are multiple. So this is just examples of how we can apply the shift left process and the tools and techniques that we saw earlier, and how we'll be looking at how the entire cycle will be looking. So that's the example number 2, where we are looking at front-end testing. There are multiple ways where you can get fast feedback during development itself, snapshots, tests, all of those functional front-end performance tests. Static code analysis could be used. And in CA, there is a lot of ways like visual tests, cross-browser coverage, user story testing, and release testing. All of those things form on fast feedback loops, shorter feedback cycles like we were talking earlier, and ensures that as we check in, the code is tested for all of these quality aspects like front-end quality, the security aspect, similarly accessibility. All of these aspects are tested for each of the code commit that is happening, and that code commit is actually in a quality that is ready to be released to production. So that's the ideal, or why we are doing so much of effort into like we spoke, imbuing quality into the software. So one of the ultimate outcome that you can get is you can also achieve the 4 key metrics. Like, some of these things will enable you to get a deployment frequency on demand, right? Like, if all of your quality aspects are tested as part of your for each of your commit and each of your incremental changes, then you have a collective code that is ready to be deployed on demand. Multiple deploys per day can happen. Your change file percentage could be very less because you have a safety net of tests that will tell you that whenever you make a change, this is the kind of issues that you are actually encountering. So all of these kind of meticulous testing that we were talking about is enabling you to achieve the 4 key metrics as well, and in turn accelerate your development process. And like we saw in the Martin Fowler graph, slowly you will see that the rate at which you are releasing software will be very high, and that too a quality software. And the last part, so we spoke about process, we spoke about techniques and tools, and the last part is the principles part. And so even though many folks actually pay attention to the techniques and tools, I think it is very important to understand the principles, because the landscape of technology is like really changing at the very minute that we are talking. There are so many new tools that are coming in. There's so many new domains that are coming in. There's like AI. There are so many IoT products. Like there are like multiple ranges of technologies that are coming in. So there could be some areas where the testing tools are established, there are testing practices are established, and there could be many areas where the testing discipline is still evolving, even though we saw a lot of breadth and depth of testing techniques and tools so far in the slides. So what will we do in those kind of scenarios is when these principles come into picture. I think fundamentally we need to put some process in place, adopt some techniques and tools in place to be able to being guided by these principles. So I think that first and foremost, defect prevention over defect detection should be one of the very key principles, because we should be, like we saw the small feedback loops, like being able to give feedback on requirements, design, very small feedback loops, iterative feedback loops that will help us get that defect prevention mechanism. Like whatever that makes it happen, right? Like it need not be the same XP practices, but in a new culture, it could be, it could be a team with different roles that have not been explored as well. It could be like a team of data engineers, data scientists. Then what is the process there? Then whatever composition of teams or roles or domain it could be, the defect prevention kind of activities and practices needs to be in place over defect detection kind of practices. Communication and collaboration. Testing cannot happen in a siloed fashion. Testing cannot be like, the testing is like outside of the development team. So testing is a well embedded process, as we were talking from the beginning. It needs to happen continuously to give fast feedback, small iterative feedbacks. So the communication and collaboration between all the roles is going to be absolutely essential to be able to give that feedback loop, make changes, make the continuous improvement process, like working with all the kinds of roles. Um, and empathetic testing is another key principle for me, because it's like when someone is wearing the testing hat, it means that they are representing the end user in that team. So end user empathy, it should be the ultimate priority. Even though you could love your team to the bits, you should be able to fight with them and say that no, the end user doesn't see value in this kind of a scenario, and please change it. This is a defect. So that kind of wearing the end user hat and being able to create that empathetic testing mindset is going to be very crucial. In micro and macro level testing, this is again another concept. Like we are talking about functional test automation, which is like starting from unit to the UI test. So when we are looking at unit, we are talking about a micro level functionality. So, and when we are talking about a UI flow test, functional test, we're talking about a macro level testing. So these kind of constant zoom in, paying attention to the smallest functionality and being able to test the boundaries of that smallest functionality in unit, and being able to zoom out and look at the macro functionality, and being able to zoom in and zoom out is going to provide a lot of value while testing. And fast feedback, we have spoken about it throughout this talk, and fast feedback is like absolutely essential, and fast feedback is going to ensure that the defect fixing cycle is going to be really faster and really easier and cost efficient. And continuous feedback as well. It's not enough that you actually follow the fast feedback principle once and you're done with it, but the process has to be continuous. You should be having some mechanism in place that the fast feedback happens on a continuous basis. So it's not like a rush in energy and you just like finish off your work and you're giving fast feedback. That's not the intention, but it needs to be on a rhythm. It needs to have that continuous momentum happening within the team, that the feedback keeps going on and the team is looking to work together to get that feedback, fix it, and be able to release it to production. And finally, measure quality metrics. And this is also one of the, I think I go by, like, for example, there are product KPIs, right? Like the product is built with the KPIs in mind. Similarly, there should be quality goals for the team. So the quality goals, when measured, will ensure that the team is moving the product towards that quality goals. Just like how there are product KPIs, there should be quality metrics where the team is putting in energy to move the product towards that quality. This is like a collective goal for the team, and combined with all the communication, collaboration, and all the CACD mechanisms, these quality metrics will really help the team to work together and achieve the same quality goals. So these are 7 guiding principles, according to me, that will help us in exploring any new domain, and which can have new roles, a new kind of setup. But the fundamentals, when in are these principles, when practices, tools, and techniques are put into, I think we'll be able to achieve that goal of continuous delivery by doing full stack testing. So all of these content are from my book, Full Stack Testing, which got released recently. And there are examples of how to actually set up some of these tests with code in it. If you want to take a look, please do. That's about it. And thank you for giving this opportunity. I'll be able to take some questions or comments.
Thank you, Gayathri. And I have actually a question. So what do you think are the most important KPIs related to testing at each level of testing? So what are the most important, and how do we show and calculate them usually?
We're talking about some of the quality metrics, I believe, like what should be some of the quality metrics. I think when we're talking about quality metrics, there are different levels we can actually tie to. One is at an engineering practice level. So at an engineering practice level, whether we are able to give a code coverage of this much percentage, whether the automation coverage is of this much percentage, security coverages of this much, performance is meeting all of those things, meeting all of the KPIs. That is like an engineering metrics that we can capture on a regular basis at a user story level. And when we tie these engineering quality metrics to a higher level, that's when we see the 4 key metrics that relates slightly to a higher level, where we are saying that these 4 key metrics will tell you how the team is able to deliver quickly. So that ties the business aspect into it, where it actually says that, okay, the team is able to make fast changes, and they're also able to make stable releases. So that gives like a slightly, so I see this as like a triangle, right? Like the pyramid format itself, where the bottom is like engineering metrics, all the quality metrics that leads to the 4 key metrics, and that leads to business product KPIs, metrics, whatever it may be.
Thank you. Actually, we have some questions in the Q&A. So the first one is, we have 3 questions in the Q&A.
Okay.
So the first one is, can the readability of a code base be considered with the bucket of in the bucket of the supportability?
Yes, yes. I think the readability aspects, I think we were talking about some of the tools which some of them actually said about the styles, like how it literally actually tells about whether you have to format it in the certain way, it needs to be indented properly. All of those styling things are available as tools in the supportability bucket of tools that we looked at. And it's very much possible.
Okay, and in the line of this question, could you suggest some tools or methodologies to address it in terms of design patterns, like the single responsibility principle or good naming convention, and in general metrics uncovered by a system like SonarQube?
So we spoke about some of the tools there. There are a bunch of tools in that slide. Will we be sharing the slide, or will we be sharing the recording? Maybe we can.
Yeah, we will be sharing the recording, yes.
Okay, maybe in the recording, there are a bunch of tools there that are that can be used in different lines, like static code analysis. Linters are available for JavaScript kind of changes, and also architecture tests. That's also going to be important in terms of the single responsibility and the uh, making it independent, reusable kind of components. So those tools can be looked back in the recording.
Okay. So another question is, in the years, the number of tests can grow a lot. So can become such big number of tests that that they need a lot of time to run locally. It happens to a lot of developers that they get stuck too much time in running local tests in their machines. So what do you have any suggestions about this topic?
So, I mean, I mean, the question says that it is a given that the number of tests will result in a long time to run. So, one of the projects that we have in ThoughtWorks, it literally has 1 lakh unit tests. And because it's a large project, it's an enterprise project, and there are more than 100 microservices and everything, but it runs all of them within 15 minutes.
Okay.
So I'm contending that statement that the number of tests is directly proportional to the time taken. There are, I mean, there are ways to cut down the time. We could also do parallelization. So it is possible to cut down that time.
Okay. Okay, and there is another question. So when a separate division of tester is a good or bad idea?
When so when a separate division of tester, what are like, I'm going to answer it in 2 ways. Like if we are talking about having a separate role called a QA, and another angle is having the testing team outside of the development team. So from those 2 angles, I can answer the question. One is the first point where we were talking about having a separate QA role within the development team, well embedded into the team processes, like starting from requirement gathering. The 3 amigos processes, like the BA, QA, and the tech lead or the developer sits together, and starting from there till manual exploratory testing, the QA is well embedded into the team. In such a kind of scenario, I think there's a lot of value add that QA can bring in. And in my opinion, I think the QA owns a kind of responsibility where they take ownership of all the testing activities, because as I said, the testing discipline has grown so much. Somebody needs to actually own the testing activities which are happening within the team as well. So the QA role can take up that responsibility, while the BA role focuses on business, and the development team focuses on building the right software. When these three roles can collaborate, the outcome can be really good. That is the first angle, where the QA is well embedded and part of the process. It's a great benefit for the team. Whereas if we are looking at team separation, where the testing team is a separate team and the development team is a separate team and the product team is a separate team, that's kind of like an anti-pattern to me. It doesn't work at all. Keeping the testing team siloed is a result. Is a result of some organization politics, according to me, where there could be that the QA team could be vendors, so therefore they have not been included into the development cycle, and some waterfall techniques, like making sure that the bugs come in. So none of those are really something that I've seen work.
Okay, thank you very much, Gayathri. If there are no more questions, I would again share my screen just to take the last minute of your time. So let me ask very quickly for your feedback. We will send a form and ask for your feedback in the next days. And thank you, everyone. Have a great evening.